Hi friends, welcome to my YouTube channel. This is second part of lecture number 23, and in this lecture we will study parameter calculation of one phase half wave controlled rectifier with RE load. So first start with average output voltage V naught average. So V naught average is simply equals to 1 upon 2 pi integration 0 to alpha e d omega t plus integration alpha to pi minus theta Vm sin omega t d omega t plus integration pi minus theta to 2 pi e dot d omega t. How we get this? We know that from 0 to alpha equation of output voltage is equals to E. From alpha to pi minus theta equation of output voltage is equals to Vm sin omega t, and again from pi minus theta to 2 pi the waveform has equation of EMF E. So that's why we will integrate the whole entire waveform in these three parts. So on integrating we get V naught average is equals to 1 upon 2 pi Vm cos theta plus cos alpha minus E in bracket pi plus theta plus alpha. So now what is I naught average? It is simply equals to 1 upon R V naught average minus E. And what is RMS value of output voltage? RMS value is given by under root of 1 upon T integration 0 to T V naught square dt. So here we get 1 upon T, here T is equals to T 2 pi, that's why we get 1 upon under root 2 pi, under root of 0 to alpha E square d omega t plus alpha to pi minus theta Vm sin omega t square d dot d omega t integration pi minus theta to 2 pi E square dot d omega t. So on integrating this we get value of V naught RMS. I naught RMS is equals to V naught RMS minus E by R. Now here load is voltage step. Voltage step means here current and voltage waveforms are similar. How these waveforms are similar? Here we can if you see the waveform of output voltage, it is like this. Okay. Again if we see the waveform of output current, then it is similar to this voltage waveform. Okay, that's why load is voltage step. Or whenever you have resistance in the load, then in that case we get similar waveforms of output voltage and output current. Here load is RE type, that's why load is voltage step. So it is a half wave control rectifier. Here output power P naught is given by I naught RMS square into R plus E into I average. But if load has some inductance in it, then in that case we get output power P naught is equals to V naught average into I naught average always. Okay, but here load is voltage step, and for current step load P naught is given by V naught average into I naught average. Now input power is equals to output power because thyristor is lossless. That's why we get input power is equals to output power. So in what is input power? It is simply equals to RMS value of input voltage or source voltage into RMS value of source current into cos phi. Cos phi is the input power factor. If we equate this with this output power, then from this equation we can get the input power factor. Now what is conduction angle of thyristor? So here thyristor was turned on from alpha to pi minus theta only. Okay, in that case we get source voltage appearing across the output voltage. So thyristor is conducting only for a period of from alpha to pi minus theta. So that's why conduction angle of thyristor is given by pi minus theta minus alpha. And what is beta? That is excitation angle. Here we can clearly see that we get current up to pi minus theta. That's why beta is equals to pi minus theta. What is peak inverse voltage? As I already told you, the maximum reverse voltage across thyristor we get, that is equals to minus in bracket Vm plus E. So maximum reverse voltage is Vm plus E. That's why peak inverse voltage is equals to Vm plus E. We have not included this negative sign here because the inverse in this peak inverse voltage itself include this negative sign. Now circuit turn-off time of thyristor. Here circuit turn-off time is the time for which thyristor is reverse bias. Here we can see that thyristor is reverse bias for the angle this, that is equals to 2 pi minus theta, and angle this, that is equals to theta. So it is simply equals to 2 pi minus theta plus theta. So we get pi plus 2 theta. So omega Tc is equals to pi plus 2 theta. That's why we get Tc is equals to pi plus 2 theta upon omega. So this is circuit turn-off time. So this is all about this video. I hope you like this video. Thank you. Jai Shri Ram. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.